So let's discuss inverses, and logs and exponents cancel out because of their inverse property. And what I mean by that is if I have a log base b to the bx, these cancel, and I'm just left with my x. And similarly, if I have b raised to the power of a log base b, if my b's are the same value, I can cancel these out, and I'm left with just x. So some examples of that would be a log base 4 of 4 to the 2x, and your 4 and your log base 4 would cancel, and you're left with a 2x. Now similarly, with this bottom part, you could say something like 5 raised to the power of log base 5 of sine x. And because the 5's match, my log base 5 and my 5 cancel, and I'm just left with sine x. So we're going to do some examples of this. So for the first one here, you can see that the log base 7 and the 7 cancel, and you're just left with 5x plus 1. On number 2 here, we don't have the same number, so we cannot cross anything out. The only thing I can see to do here is take this x plus 1 and bring it down in front. Remember, those are our log rules, that if you have an exponent, you can bring it down in front. Now this next one here is nice. It has the 6 and the log base 6. We can cancel those, and we're left with x squared. All right, moving forward with some more practice, the log base 3 and the 3 cancel, and we're left with 2x plus 5. The log base 3 and the 3 cancel, we're left with x plus 2. Now this next one, because it's a log base 4, and then this is kind of in the, I wouldn't say, it's not in the subscript, so we can think of this as being in parentheses, and the 4 log base 4 cancel, and I'm just left with an x squared plus 1. Now this next one's really important. I would go ahead and star this in your notes. We can first attack this problem by saying that we have 4 times an e to the 3x. So using my log rules, I can write this as natural log of 4 plus natural log of e to the 3x. Now you're going to start to recognize the fact that a natural log of e cancels, but let me kind of prove that to you. So let me rewrite this ln 4 because that's not going to get any simpler. But we should recognize the natural log as log base e. That's the same thing as ln. And then I need to rewrite my e to the 3x. So here you can see that this log base e and the e are going to cancel, and my final answer is going to be to rewrite that ln 4, or natural log of 4, and then I'm just going to have plus 3x. And so from here on out, if you recognize this right here, as soon as you have a natural log of e, you can think of those as being cancelable because it's a log base e raised to the e. All right, here's some harder ones. I want you to think about simplifying first and then going ahead and attacking this. Well, for the first one, we can rewrite this as an e. Natural log of 5 can be written as a log base e of 5. I try to make that e a little smaller. And then squared. Well, what do we know about e and log base e? Those are going to cancel. And so we're left with a 5 squared, which is 25. And I'm going to emphasize this again. This is an important problem right here. But now, whenever you see e to the ln, we know that those are going to cancel, and you're just left with 5 because, just as a reminder, our natural log, our ln, is log base e, which means your e would cancel with that e, and it would disappear. All right, this next one here, there's an invisible number here. Remember, we talked about this. If it doesn't have a base, if it just says log, it implies that it's a base 10. So this is going to be a log base 10 of 10 to the 5th. Well, here my log base 10 and my 10 cancel, and I'm just left with 5. This next one here is a log base 10, and a 5, so I can't have anything cancel. The only thing I can do is take my x plus 1 and bring it down in front, and you do need to remember parentheses, or else it's technically incorrect. All right, we're getting better, so let's go ahead and immediately cancel out the e to the ln, because we know that's going to be e to the log base e. And so this is going to be a 2 cubed, which gives us 2 times 2 times 2, which is 8. This next one's a little bit easier. We've got our log base 4 to the 4, so we have our answer of just plain old 2. All right, this next problem, let's go ahead and start it. It's an important one. But remember, we can rewrite this as ln 8 plus ln of e to the 5x. Now, I hope you're getting used to understanding that the natural log of e cancels, and so you'd just be left with 5x on that second term. But if you don't believe me, I'll rewrite it, which is always a nice, easy way of seeing it. So remember, natural log ln is the same thing as log base e, so these would cancel. And I'm just left with natural log of 8 plus 5x. So this next one is a fun challenge problem. It seems really scary, but you have to remember that when you have natural log or any logs and there's subtraction, you can rewrite that as division. So this is going to be equal to e to the ln of a 4x divided by 2. Because remember, just completely ignore this e for a second. We can take this, because it's subtraction, and make it division of the top divided by the bottom here, and then you're just going to write 1 ln. Well, now, if you look at this, we have e to the ln, and I'm really hoping we recognize that these cancel now, and we're left with a 4x over 2, which is equal to simply 2x. All right, that's it for this video. There is one more to watch today. Thanks for watching.